Hello, my name is Andrew Sagoon, and today I will be explaining some basic trig identities as well as how to use them. So first I'm going to be covering quotient identities, and the first one is tan theta equals sine theta over cosine theta as long as cosine theta is not equal to 0. The reason that cosine theta cannot be 0 is that it would make this whole expression undefined. The second one, cotangent theta equals cosine theta over sine theta as long as sine theta does not equal 0. Sine theta can't equal 0 for the same reason that cosine theta can't equal 0, because it's in the denominator, and if it were 0 it would make this whole thing undefined. So those are the quotient identities. So next up I'm going to be covering reciprocal identities, and these all basically state that each trigonomic function is equal to 1 over its reciprocal, as long as its reciprocal does not equal 0, as that would make each expression undefined. Next I'll be covering Pythagorean identities, and what these basically state are that cosine squared theta plus sine squared theta equals 1, cotangent squared theta plus 1 equals cosecant squared theta, as well as tan squared theta plus 1 equals secant squared theta. So now that we know some basic trig identities, let's move on to some examples. So for our first example, we've got in parentheses cosine squared theta plus sine squared theta, then plus tangent squared theta. So first thing you're going to want to do is, if you remember from the Pythagorean identities, cosine squared theta plus sine squared theta equals 1. So now we're left with 1 plus tan squared theta. And another Pythagorean identity was that 1 plus tan squared theta is equal to secant squared theta. So that would be your answer to this example. For our next example, we've got secant theta times sine theta. And if you remember from the reciprocal identities, secant theta can be rewritten as 1 over cosine theta. So now we're left with 1 over cosine theta times sine theta. And from here you just multiply them. So you're left with sine theta over cosine theta. And from the quotient identities, sine theta over cosine theta is equal to tangent theta. And for our final example, we have sine theta times secant theta over secant squared theta minus 1. So for the numerator, we can repeat what we did in the last problem. So we can rewrite secant theta as 1 over cosine theta times sine theta. And if you look closely at the denominator, you'll notice that it's similar to the Pythagorean identity tangent squared theta plus 1 equals secant squared theta. And that's because all that really happened in the denominator over here is the 1 switched sides to secant side. So we're left with secant squared theta minus 1 is equal to tangent squared theta, meaning we can rewrite the denominator as tangent squared theta. And do some simplifying in the numerator will give us tangent theta over tangent squared theta and we just divide out the tangent theta, which will leave us with 1 over tangent theta. And from the reciprocal identities, 1 over tangent theta is equal to cotangent theta.